Let's do the first problem. And this is a problem topic is the first law of thermodynamics. Okay? So thermodynamics is a topic that you will learn in your, I guess, the first portion. And the thermodynamics is, thermo means the heat and energy and how those transactions are being made. And the first law of thermodynamics can be simplified by this equation shown as here. Delta E is Q plus W. Okay? And other people will use a notation U instead of E. And this means actually internal energy. And that's an equation summarizing the first law of thermodynamics. So for a system, their energy state, internal energy state can go up, can go down, depending on the transaction from your surrounding. And the Q is a heat, and the work is, W is a work. And this problem is actually, I think you have a similar problem in CHEM1. Actually, pretty much identical problem. So it's they want to recap about the sign. When Q is positive, how the Q is being done. So here, this is a system. As I draw the circle, and that is your system. So thermodynamics is important to actually re-ask yourself how the system is defined. And then this is a system, I just draw the circle. And the system absorbs the heat. Okay? So I will put an arrow like this. System is absorbing the heat. This means heat is positive. And then that's a 0.30 Kelvin. What about work? Work is performed onto it. It means a system. So that means your work is performed onto the system. That is a positive work, and 0.70 kilojoule. And then there is a delta E, which is the internal energy. So what that means is because of the heat transaction and the work transaction, your internal energy was initial, is changing onto the final internal energy. Delta E is final state minus initial state, right? So and that's how the whole thing's worked out. And then you can say delta E is Q plus W. Because of the sign, this is 0.30 plus 0.70 kilojoule, 1.00 kilojoule. Which is a positive. Right? So your internal energy goes up, and that means you're absorbing the heat and the work from the surrounding. So your net internal energy goes up. That means energy absorbing process. So therefore it is endothermic. The opposite of endothermic is exothermic, right? Exothermic means you're releasing the energy, so your internal energy goes down, your enthalpy goes down, and then those energy of your system decrease is liberated in a form of the heat. So this is an internal endothermic process. And this is the one that I'm going to post the answer key, what I wrote it down, so you can download the PDF file with my annotation in it. And this is actually what was given out by the Dr. Ma, that what is the answer key for what's provided to me. And that's the one that you will see that this is my version of the answers. Okay? So you have both information. Okay.